Okay, so last week we looked at conic sections, we looked at hyperbolas, we looked at ellipses, and we looked at parabolas. Today we want to look at those conic sections as they are shifted. So they will not be centered at the origin, they'll be centered somewhere else. And that's what we want to take a good look at. So the first form is this. If we take a parabola and shift it, we get y is equal to a times x minus h quantity squared plus k. That would be the form of a shifted parabola. That is a vertical parabola. A horizontal one would be x equals a times y minus k quantity squared plus h. That shouldn't be too surprising to you. Some people really looked at that form and they were questioning it. You had that during advanced algebra 2 or honors algebra 2. You also had at the beginning of college algebra this year, so we've seen this before. The vertex sits at HK. That's why we like it, because we can look at it and see exactly where the vertex is right away. Now an ellipse, if we shift an ellipse, similar things. We use h and k, but in this situation we come up with x minus h quantity squared over a squared plus y minus k quantity squared over b squared is equal to 1. So instead of an x squared on top and a y squared on top, we have the hk. And that shifts the center. Instead of it being at the origin, the center again is at hk. Anybody know if that ellipse is shifted or is stretched horizontally or vertically? Yeah, it matters in an ellipse where the bigger number is. And a is the bigger number for an ellipse, and so this one will be stretched horizontally. So I will do one now vertically. We simply have x minus h quantity squared over b squared plus y minus k quantity squared over a squared is equal to 1. Regardless of where the a value is, whether it's under x squared or y squared, the center is still going to be hk. That's correct. And for a hyperbola, we'll go like this. X minus h quantity squared over a squared minus y minus k quantity squared over b squared is equal to 1. Now, is that hyperbola, is that a horizontal one or a vertical one? What makes it horizontal? Because the x is first, the x is positive. That really makes a big difference. So you could switch it, make it vertical by going y minus k quantity squared over a squared minus x minus h quantity squared over b squared is equal to 1. And there again, the center will be hk. What's that? Yep. So the only thing we've done is we've replaced some of the pieces with hk. That's it. So that the center or the vertex moves. So it has a new position. Everything else we learned about distance from the vertex or foci or anything like that, that all really stays the same. They move along with it the same way that you have hk move. So the question though is, if you look at problem number 1, problem 1 says place the following conic section into its standard form, graph the conic section, and identify all important characteristics. So we have 3 of these problems. The first one's the most difficult. The question is, as you look at that first problem, it's not sitting in a form that I can recognize like one of these. So I need to place it in that form. Before I place it in that form, do you have a general idea right away whether it's a hyperbola or a parabola or an ellipse? Why do you say ellipse? Okay, that's a very good idea. And you're right on a few accounts, Parker. Unfortunately, it's not an ellipse at the very end. And let's identify why. In order to be a parabola, you need to have one of these two. Either x squared or y squared, not both. So you can see as you look at this example here, as we look at the forms, you have a y, but then you end up with an x squared. You have an x, and you end up with a y squared, but you don't have both of them squared. So in this example here, do you have an x squared and a y squared? So it's definitely not a parabola. In an ellipse, you have x squared and y squared, and they are both positive. As you can see, you end up with an x squared and a y squared in an ellipse, and because I have a plus sign in the middle, they will both be positive. Are both your x squared and your y squared positive in this one? Nope. So then I move on to the hyperbola, and you're going to have x squared and y squared. One is negative. If you came out with both of them negative, that would really mean that they're both positive. We would divide through by a -1. And there are examples where you could come up with conic sections that are degenerate. You don't actually get a result. We're not going to focus on those, but it is possible. So, all right, it says place the following into its standard form. Let's start by placing it in a standard form. And this is really where the anxiety started. Hopefully we'll be okay. As you look at the equations above, they all have a completed square, right? All have a completed square. I have to complete the square for this one. So I have 9x squared minus 72x I'm going to place that in parentheses. So I have my x's all gathered together, for which I'll complete the square. And then minus parentheses 16y squared plus 32y equals 16. Now why did I make that a plus 32y? Because I have the negative out front. So when I complete the square, I like to, for a hyperbola, I like to have my x's on one side, my y's on that same side, and all my constants over on the other. So if I complete the square, what should I factor out of here first? A 9. And out of the second one, a 16. How do I complete the square? How do I do that? What's the process? You take the b value, divide it by 2, and square it. So I get 16. And then let's do the second one, and then we'll do our balance here in a second. How about the next one? Okay. Now, I can't just add stuff into to one side without doing it to the other side, because this is a balance, and I've done some things on one side. I have to do the same to the other side. So, what value did I truly add over here? I didn't add 16. I added 9 times 16. That's the value of this, which is 144. So you have to add 144 over here. And then we have what's the value of the other one? Negative 16. So we have 16 and negative 16 will cancel, and you'll just be left with 144 on the other side. So now we can complete the square, or the square is completed. Now we just write in its factored form 9 times x minus 4 quantity squared minus 16 times y plus 1 quantity squared equals 144. And what's the last thing I need to do? Divide by 144. So we have x minus 4 quantity squared over 16 minus y plus 1 quantity squared over 9 is equal to 1. There we have it. It's in its appropriate form. What's that? Yep. Now we need to graph it. We need to find all the interesting characteristics about it. And I'm going to encourage you that as you identify a characteristic that we graph it as well right away. So let's start with the easy part. What's the center of this hyperbola? 4, -1. Remember, it's opposite of what you think on the inside. I look at my, from up above here, it says that for a hyperbola, if it's a -h and a -k, then the center is hk. So we have a -4 and a +1, so it's going to be +4 and -1. One, 2, 3, 4, -1. Red marks the center. All right. Got that done. Let's move on to vertices. Is this going to be a horizontal or a vertical hyperbola? Why is it horizontal? X squared is first. How many units will it be stretched horizontally? 4 units horizontally. So from my center, I move 4 units in each direction. So that would be 1 vertice right there. I move 4 more units. I'll put another vertice right there. So those are my vertices. What are the coordinates of my vertices? 0, -1, and 8, -1. So I think it's more helpful to draw it first and then identify those pieces. Transverse axis. What's the length of the transverse axis? 8. Transverse axis is the distance between the 2 vertices. Foci. Foci are C units away from the center along that transverse axis. So how do I figure out the foci? A squared plus B squared equals C squared. So 16 plus 9 is equal to 25. So C is equal to 5. So if I move 5 units from the center, I'll be 1 further than my vertices. Those green dots are my new foci. What are the coordinates of those foci? -1, -1, and 9, -1. What's the last thing I need for a hyperbola? Asymptotes. And asymptotes are lines that the graph touches or approaches but never touches. And in order to draw the box for my asymptotes, I'm going to have to stretch this thing vertically. How many units vertically is this going to be stretched? 3, because you have 9 in the denominator. So I'm going to go ahead and 1, 2, 3. So I'm going to, in red marker here, I'm going to stretch this box 3 units in each direction. So this red box outlines where my asymptotes will pass through. Do I now have enough information to draw my graph? I sure do. I'm going to start at the vertex and follow along the asymptotes. And there's my graph. So I've drawn the asymptotes, but I need equations for the asymptotes. This was confusing to everybody during the course of second hour. They wanted to just list the asymptotes right away as y equals plus or minus, say 3 over 4x, because 3 was my rise and 4 is my run. But this is not correct. If those are my lines, what's the y-intercept of that line? 0. Do either of these lines pass through 0, 0? No, they don't. Because our center is moved, the equations for the asymptotes need to have a y-intercept. So let's set up 2 equations for lines for asymptotes. And in order to write an equation for a line, I need slope. And I need a point on the line. Now, what's nice and easy for us is that this information is pretty much given. Can somebody identify what point on the line both these asymptotes pass through? Your center, yep, which is 4, negative 1. And then m is your slope. What is the slope of these? What is as you look at the box, what's the rise of the box? 3, what's the run of the box? 4. So we have positive 3 over 4, or we have negative 3 over 4. So those are our 2 pieces. So we want to write equations for lines given those 2 things. Y equals mx plus b. So y equals, y is negative 1, m is 3/4, x is 4, plus b. So negative 1 is equal to 3 plus b. Subtract our 3. Negative 4 is equal to b. So I have one equation, y equals 3 over 4x minus 4. And my second one, again, we have negative 1 is equal to negative 3/4 times 4 plus b. Negative 1 is equal to negative 3 plus b, or 2 is equal to b. So y equals negative 3 over 4x plus 2. Those are the equations for my asymptotes. So I just wrote equations for lines. I just did 2 of them. And we are finally done with the first example. That is the longest example. Any questions on that? Questions going once? Twice? 2.5? 2.8? Okay, flip it over. Is this one a hyperbola, ellipse, or parabola? Parabola y. So you have the x squared only. What I'm going to do is I'm going to rewrite this as 8y minus 28 equals x squared minus 4x. Why? Because I want to. I think to help you guys organize your thoughts, I think it's easier when the y equals is on the left side and the x is on the right-hand side. So all I need to do is complete the square. I don't have to factor anything out of the x squared. What number do I add here to complete the square? Plus 4. So what do I need to do the other side? 4. So my new equation is 8y minus 24 equals, looks like I'm going to have x minus 2 quantity squared. Now I need to solve for y, so what will I do? I'm going to just add the 24, then divide by the 8. I took this, divided by 2 and square. Completed the square. Yep. So I have 8y equals x minus 2 quantity squared plus 24. Divide by 8. y equals 1 over 8 times x minus 2, quantity squared, plus 3. Beautiful. So, we're going to graph this. I have to identify all the important characteristics about it. What is the vertex? Vertex? 2, 3. So I'm going to move over 2, up 3. My vertex. How about this? The direction. Does it open up, down, left, or right? Up. Axis of symmetry. Axis of symmetry takes this thing and divides it right in half. What's the equation for that line that I just... X equals 2. X equals 2. I now need the focus, the directrix, the length of the lattice rectum, and the focal diameter. There's a special value I need to find in order to find those other 4 pieces. What is it? P. How do you find P? A, which is 1 over 8, equals 1 over 4P. What is that going to make P? 2. So that means that the focus sits 2 units away from the vertex. So I'm going to take this and I'm going to plot my focus. 2 units away. What is that coordinate then for that focus? Yep, 2, 5. The directrix will be where from there? 2 units down. So the directrix is a line that passes through there. What's the equation for that line? Y equals 1. Length of the lattice rectum. Twice the p-value. 4. Focal diameter, twice that. 8. So, if I were to move 4 units to each side of the focus, I would have endpoints of the focal diameter. That is my focal diameter. The parabola starts at the bottom here. It heads up. A very nicely shaped parabola. Those are those pieces. This piece right here is the focal diameter. Whoop. And this distance away is the length of the lattice rectum. Is that one better? You're hanging in there. I see the excitement on your faces, the enthusiasm. Ryan McLaughlin is saying to himself, my gosh, I need a pick-me-up. Give me a Mountain Dew. You what? You have a Monster. No, that would be illegal, right? However, did you go see the Avengers this weekend? Was it good? So I should go see it? I'm excited for it. I'm going to try to set aside a date night with my wife next weekend. So I need somebody to watch my little monsters. So we'll see. I just might drop them off at one of your houses, and we'll see what happens. I would like to trust whoever I have them with. What's that, Levi? Why don't I bring them with? Your dates sound like a lot of fun. Let's bring little kids along with. Yeah, sounds like a good time. Maybe that's why you haven't had a date for a while. Okay, all right, we move on. How about this one? Hyperbola, ellipse, or parabola? Ellipse, because you have x squared and you have y squared. Okay, we have x squared and y squared. So here I go. I have 2x squared minus 12x plus y squared plus 6y equals negative 26. What number do you need to add to complete the square? What? Oh, I should factor. What should I factor out first? 2. X squared minus 6x plus y squared plus 6y. So what number do I add in to complete the square? 9 and 9. So what did I really add? 18 and 9. Well, this works out really nice. It's like we're going to have 2 times x minus 3 quantity squared plus y plus 3 quantity squared is equal to negative 26 plus 18 plus 9 is 1. It looks like an ellipse, except there's nothing in the... Starts with D. Denominator. There you go. There's nothing in the denominator. Let's put some things in the denominator. If I'm multiplying by 2, then what goes in the denominator? 1/2. So this is x minus 3 quantity squared divided by 1/2. Instead of multiplying by 2, I can divide by the reciprocal. That way I have something in the denominator. I know what to work with. Plus y plus 3 quantity squared divided by uno. Spanish for 1. Equals 1. Now, let's identify some important characteristics. We're almost there. Center is positive 3, negative 3. C for center. Looks like I need vertices. Is this stretched vertically or horizontally? Vertically, because 1 is bigger than 1/2. 1 sits under the y, so it's stretched vertically. How many units? Square root of 1 is? So 1 unit vertically. So I'm going to have a vertice there and a vertice there. What are the locations of the vertices? 3, negative 2, and 3, negative 4. Very good. What's the length of the major axis? 2. 1 unit in each direction. Here's where we fell apart last hour, or second hour. Minor axis. Minor axis has to deal with the b value, right? Well, I know that b squared is equal to 1/2, correct? So that means that b is equal to the square root of 1/2. Square root of 2 over 2. Very good when you reduce that, or 0.7071. So the minor axis, so I go 0.7071 in each direction. I'm going to do that. I now have enough information to sketch it. So the length of the minor axis is going to be twice the square root of 2 over 2. What's twice the square root of 2 over 2? Square root of 2. And there's one last characteristic we need to find, too. We need foci. And we need eccentricity. We'll get to eccentricity in a second. Foci, I use the formula. C squared is equal to A squared minus B squared. Or C squared is equal to 1 minus 1/2. So C squared is 1/2. When I square root 1/2, what do I get? Square root 2 over 2 again. So from this center, I move the square root of 2 over 2 up and down. So what is going to be the location of my focus points? What's the x value of my focus points? 3. And then I'd have negative 3 plus the square root of 2 over 2, right? And I have 3 and then negative 3 minus the square root of 2 over 2. And how do we define eccentricity? C divided by A. C is the square root of 2 over 2 we decided. Divided by 1 is the square root of 2 over 2. Eccentricity is C divided by A. That is it! I apologize because I didn't anticipate for this to be as draining as it was. But I realize that when you have to go back and reference old learning, like completing the square and stuff, that gets difficult for people. So here's your assignment, 6 problems. These are already in form. Oh, the 797? That was Fridays. That's the new one. Damn. Dude. Oh, that was Fridays. And I do apologize because I know a lot of people have been gone, but you know it is that awkward piece.